In the next few pages, I'm going to be going over the review guide. It's not in a particular order. It's kind of the order that we did them in class. I think I started on the second review guide actually, but actually I take that back. Just kind of go through it if you need to pause the video to find the questions. I'm going to be going over questions from the two different review guides and kind of talking about what's necessary for the test, what I need to remember, what kind of work we need to show. If you have any questions beyond this, let me know, send me an email or things like that, and I'll try to answer them as best I can. Have a great day. We're going to be trying to reevaluate how to find the determinants of a 3x3 matrix using the lattice method. The first step is to write the first two columns out beside it. Now that's really just for us to be able to multiply easily. I don't really need to worry about much else. You're going to go down the first diagonal set, and each time you're going to do the first diagonal plus the second plus the third. And so I'm just going to write this out. 2 times negative 4 times negative 2 plus 4 times 5 times negative 3 plus 1 times 4 times 3. So I'm going to go down the diagonals. Remember, we're always going to do it in this order. 1, 2, 3, 4, 5, and 6. Those are the orders that we do the diagonals in. The second set of diagonals, we're going to go up like this, right? So we're going to go minus, and we're going to be subtracting each one of those diagonals. So minus negative 3 times negative 4 times 1 minus 3 times 5 times negative 2 minus negative 2 times 4 times 4. Notice I didn't really try to simplify as I went. That is a lot of numbers. That is a lot of opportunities for you to simply drop a negative sign or forget to drop one if you actually multiply them together. That's a challenge. So be careful and make sure that you're taking this one at a time. At this stage, I'm going to go in and kind of evaluate what each one was. So the first product, you got negative 2 times negative 4, that's 8. 8 times negative 2 is negative 16. Plus, and we have 20 times negative 3, so it's negative 60 plus 12. Then we got 3 negative signs in a row. If I've got a negative number, or an odd number of negative signs, that means I'm going to be subtracting. So it's going to be minus 12. And then the next one, it's going to be minus, but that's always, that's an even number of negative signs, right? So I'm going to be adding, so it's going to be 15 times 2, it's going to be plus 30. And the last one, here again, I'm going to be adding again. It's 8 times 4 plus 32. The good news is that I can do this in a calculator. I can check my work, and I can know that I'm right, or I know that I'm wrong. All right, so if we look at these, what do we come up with? So that's 0. This is going to be 62. Negative 16, this is going to be negative 76 plus 0 plus 62. So what does that give me? Negative 18? Actually, that's not 18. Got to subtract right. It's negative 14. Remember that you can check this work in the calculator. If you go to Matrix and you go over to Math, the very first one that you find is DET. If you hit enter on that, and I put mine in Matrix A, basically you want it to show this on your calculator. And you hit enter, that's going to tell you what the determinant is. Be careful. Make sure that you entered your matrix correctly into matrix A. If you type it in wrong, there's no hope. Okay, you can't get it right. You're going to get it all wrong anyway. So make sure that you type it in right here. Make sure that you write these things down correctly when you're working things out. Okay, on a test, to get full credit, I want to see this product. Now, whether you write it out like I did individually here, or you multiply it together as you go along, okay, I'm okay with either one of those steps, but I want to see 1, 2, 3, 4, 5, 6 values, okay, as you're showing me the work, right? So if you had this line and then your answer, that I would be totally okay with that, but that would be the minimum I would want to see. What are the 6 products you're going to have, right? And then kind of give me the solution here. And I would most definitely be checking my work in the calculator. This is a test where you will know your score before you turn the test in. You'll know if you got it right or wrong. You should, well, need to rephrase, you should be able to. Whether you have time to do that is maybe a different story, but determinant, I can check it. Okay? Questions about anything else? I want to take a bit of time. I want to do one like 13. Now, but this is the second review guide, so if you're curious on where I am. So this is review guide number 2, number 13. I want to take a minute. When you do this by hand, right? Now this could be anything like a word problem where you come up with an equation, or it could be something like this where you've got 2 matrices added together. Now this one's a really easy one because really I don't have to do any kind of magic. I've got a matrix X, which I don't know what it is. That's not a single number, it's a matrix. It's a 2 by 2 matrix. And I'm going to be subtracting another matrix to get this one. So just like you're used to adding and subtracting regular numbers to equations, we're going to be adding a matrix -4, 6, 0, 0. I'm going to be adding that number over here. So -4, -16, no, -4, 6, 0, and 6. So when you have matrices that are adding and subtracting, or even scalar multiplication, those are super easy to kind of work out. I'm going to be adding those 2 values together, so we're going to get a solution of -10, -22, -6, and 11 to be matrix X. So it's really just adding and subtracting like terms at this point, and I can kind of go with it from there. If we kind of keep the same principle going, if you had a matrix like this one that's got a scalar multiplier on it, well, normally if you had this kind of equation, you would divide by 3. Well, we don't really divide, but we are going to do the same thing. What we're going to do is we're going to multiply this side by 1/3 and multiply this side by 1/3. So X would become 4, 4, 1, 2. I just literally multiplied each value by 1/3, or essentially divided by 3. Any questions about that? This is an example, number 14, or even number 13, where I really am not looking for a lot of work. Those are some operations that you genuinely can do in your head, right? And so I'm really not going to knock you down for something that can be really done very quickly and easily. It's matrix multiplication, solving systems, and this one, finding the inverse, are the ones I want to see most of the work. And I'll try to keep that in the instructions where it says show the work provided for full credit, right? Make sure you do that. Even the digital tests, right, if you're taking it at home, you're going to have to work this out on paper, and you're going to have to upload an image of your work. So let's do the inverse. The formula for the inverse is, and I'll give you the formula, A inverse equals 1 over AD minus BC. The AD minus BC, just that bottom part, that's the determinant of a 2 by 2. Remember, we switched the A and the D values. I just switched their positions. I don't do anything else. Don't change their signs. I just change their places. But I do change the sign of B, and I change the sign of C. Be really careful. That's not negative B, negative C. It means whatever they were to begin with, you change their signs to be the opposite. So let's find the determinant first. That's the first thing I'm going to look for. -4 times 1 minus -9 times -2. So we're going to get -4 minus 18 to get -22. Here again, I'm not really opposed to pulling my calculator out and doing some of these things, right? To double check my work, but I've got the process down on the paper, which I can see that I understand, or that you understand. So 1 over negative 22. I'm going to reorder that matrix, 1 and then negative 4. We're going to go 2 and 9. Now I'm just going to distribute through. Now let's be clear. Some of the questions are probably going to be multiple choice just to kind of help you with time. If you had a multiple choice question like this, your solution could come in one of two ways. It could look just like this, where it's not multiplied through, or you could see it written kind of where you distributed the matrix, or the fraction into it, right? So you got negative 1 22nd, and you have negative 1 over 11, negative 9 over 22, and 2 over 11. Either way, either of these sides of this particular solution you can see right here would suffice as solutions. Now, if it's free response, I expect it to look like this. Go ahead and multiply it through and finish it out, okay? But sometimes multiple choice may show up like this or like this. Either way, I think you'll get the right answer. When you get in a system of equations, like this one, okay, the solution method has always been in the calculator. We really haven't even discussed 3x3 solutions. You can use elimination and substitution to do this, but we have always done it with a matrix, and we've always written it out a certain way. This is actually a really, really easy question. There's only 2 steps, and we're going to use our calculator to get it. The first thing I look for in this kind of problem is going to be the matrix equation that represents the system. And so first thing we write out is our coefficient matrix. So it's going to be 2, 3, negative 1. This one's going to be 0 because there are no x values in that list, so I have to replace it with 0. We have 2, we have 3, we have 1, negative 1, and 3. This is my coefficient matrix. The second matrix I'm going to write out is the variable matrix x, y, and z. Now that's important because I wrote it down in that order. I put x first, I put y second, and I put z third, right? So every time I write that out, if they're out of order, then when I go to do the problem like this, I won't get the right solutions. And that's going to be equal to those constant values, 4, 6, and negative 12. Okay, now I just made this up, so the solutions here probably aren't going to be very nice. They might be. The way we're going to work this out is we're going to type this into matrix A and this into matrix B in our calculators. Okay, I'm going to work this out, and we're going to do A inverse to cancel that matrix out, leaving me with just the x, y, and z on the left side. And on the right side, we're going to multiply the same thing in the same order. If you do it out of order, it won't even work. So here we're going to get that, and I don't know what the answer is because I don't have time to do it out, but you would get the solutions, and you would put those in right there from the A inverse B inside your equations. Okay? So you will see things like this on the test, so be prepared for it. I want to address one more question before we finish up. Question 6 has multiplication and addition involved. So the first thing I'm going to do is I'm going to first check to see if it's even possible. And I know that if I multiply 2 by 2 times a 2 by 2, it's totally fine, and I'm going to get a 2 by 2. Can I add a 2 by 2 to a 2 by 2? Yes. So it means it's possible, so I'm not going to waste my time by trying it. But we had a discussion about PEMDAS. You're taught PEMDAS looks like this, but that's not true. Sorry, if you thought that was true, it's not. I know, right? It's really more like this one. When you get to multiplication and division, it's not that multiplication always comes first. It's that if you have an order, if you have operations that, and you're going to do it from left to right, right? You get these problems the math problems that break the internet or whatever, right? It's because people don't know how to do order of operations. Legitimately, that's all the problem is. And if you follow this blindly, you're going to get it wrong. When you have multiplication, division, or addition and subtraction kind of stacked together, you're going to do whatever comes first, left to right. So you do the exponents, you do the parentheses, do all that stuff first. That is definitely going to happen that way. Exponents first, then parentheses, or parentheses, then exponents. Then from left to right, you do all the multiplication or division, whichever one comes first. Right? So you had this times this divided by this plus this. You're going to do all of that multiplication or division in the order from left to right. Same thing with addition and subtraction. If I have this number plus this minus this plus this minus this, start from the left and just walk your way over. In some instances, it may not matter which way you do it. In some, it definitely will. Okay? Like if we're multiplying a bunch of stuff together, it doesn't really matter. But if you're multiplying and dividing, it would matter, right? So do it as you come to it. So for this one, you're going to multiply first and then add. So that really didn't matter a whole lot, right? Multiply always before you add or subtract. For this equation, or for this setup, this is the review of the word problems we did last week. I think we did some of this on Friday and a little bit more on Monday. You guys have plenty of exposure, plenty of examples to look up. You can go back and download that big sheet. You can download this copy. You can find that. So this is the first one we did. I think it was last Friday. Go back and look at these. You can print off the original. This is the key, so you can look at it either way you want to. What we're doing, we're looking at this. I'm going to give you an equation, a paragraph that's going to have quantities, just like this one's got tickets, this one's about flowers. Here's a 2-sample example, and this is a 3-sample example. Here, I need to identify the 2 quantities. In this example, you had tickets and money. This one, we had 3 different things. You had the amount of money spent, you had the number of flowers that you had total, and you had this weird relationship between roses and the other 2 flowers. If I have 3 variables, 3 unknowns, I have to write out 3 equations. If I only have 2 things I don't know, 2 equations. And you can see that listed here. For the first one, x plus y is 452. So the number of tickets for the children and for the adults, we were told that they had 452 tickets sold total. The amount of money, so the number of student tickets times 0.75, the number of non-student tickets times $2 is going to be equal to $429 total. And so here you got these things set up. If I plug this into a matrix, it's going to be 1, 1, 0.75, 2. And then you're going to have x and y, and you're going to have 452 and 429 inside the equation, or inside the matrix. You're going to do A inverse B. Of course, your coefficients are A, your constants are in B. They're going to give you the solutions like you see here. There is a video specifically of me going over this already, so I'm not going to take the time to write it all out. You can go back and check that out whenever you need to. Here again, the same thing is true for the 2-sample or the 3-sample ones. I'm looking to see the different quantities they have, flowers, right? So here's flowers right here. Remember, there's 5 bouquets and 20 flowers each. That's where you're going to get that 120 flowers total. You've got the money value, and then, of course, you've got the relationship. The roses is twice the sum of the other 2. That's literally changing English into mathematical terms. So keep in mind, I think if you can get this one, if you understood how to do that part, I think you're going to understand how to do the test. I don't think they're going to be any more difficult than maybe that one. Any questions? The other ones we did were a little simpler, where you had like 2 numbers add up to 20 and then 2 numbers subtract to get 12 or something like that. You had to find the 2 numbers, right? It's about writing the equations and solving for those missing pieces using the matrices. Okay? So I'm back on, this is the first review guide. This is problem, we're going to look at number 20. So here we have kind of a full-on equation. We're going to have to solve this equation using a bit of adding and subtracting matrices and, of course, multiplying in the end. I think these kinds of questions, this is a lot like solving the system with the word problems. These are where you're going to find the most of your work. Okay, you're having to multiply by inverses and all that stuff. Step number one is to get this matrix and combine it with that matrix because they're like terms, because I can't divide or multiply by the inverse until I get it to be equal to that. Rule number one, when you're solving equations with matrices, you're looking for the matrix next to the variable. Now that y is just another matrix. Okay, in this case, these are all 2 by 2s. So when I solve for this y, I'm going to get another matrix. That's the matrix I'm going to have to find the inverse of, right? So I need to get this matrix equal, or this whole expression here equal to another matrix, not two other ones. So we're going to subtract this matrix here. So we're going to do minus 1, negative 9, 5, 9. So in this case, we're going to end up getting 6, 0, negative 3, negative 1 times some other matrix y equal to negative 35 minus 1 is negative 36. 9 minus negative 9 would be 18. 26 minus 5 is going to be 21. And then negative 2 minus 9 is negative 11. So step number one is to combine kind of the like terms. Step two is going to be kind of finding the inverse of this matrix. So we're going to do, it's going to be 6 times negative 1 minus 0. So we're going to get negative 6 as the determinant. So the inverse is going to be 1 over negative 6 times negative 1, 6, positive 3, and then 0. So I switched them. We're going to multiply through by the determinant now. So we're going to end up getting positive 1/6, 0, negative 1/2, and negative 1. So if I'm grading this, right, obviously step one would be me finding by adding that other matrix to the other side. That'd be the first place you can get some points. Step two would be finding the determinant. Step three would be to find the full inverse. Now what we're going to do is we're going to bring this matrix down here and multiply them together. So negative 36, 18, 21, and negative 11. Okay. Here again, I'm really not opposed to you using the calculator to help you do this multiplication, but writing the process down, it's going to be kind of important to get full credit. So I'm going to go ahead and I'm going to multiply. Remember, we're going to multiply across the first matrix, but we're going to go down the second matrix. Across the first, down the second. That's always how it works. Remember, it's a 2 by 2 times a 2 by 2. So we know that it's possible. So yes, and the solution is going to be a 2 by 2 as well. That's how you can determine by looking at the dimensions of that original two matrices, how I can find out, is it possible, number one. Number two, what's my solution size going to be? So we're going to do 1/6 times negative 36 plus 0 times, I don't care, because it's just 0. So I'm not even going to bother putting the next part down. Let's do it again. We're going to do 1/6. So now I'm going across the first row still, but now I'm going to go down the second one, okay? And so 1/6 times 18 plus 0 times negative 11, but it's just 0 again, so I'm just not going to worry about that. Now we're going to go to the bottom. It's going to be negative 1/2 times 36, negative 36 again, plus negative 1 times 21. We're going to go to the last, so now we're in the bottom row. We're going across here, but now we're going to go down with these two numbers. We did those two first, now we're going to do these two. So it's going to be negative 1/2 times 18 plus, this will be negative 1 times 11, so we're just going to put 11. Any questions on how that math process happened? Now, at this point, if you did the work already and you did it in your calculator and you already know the answer, you get a chance to double check that here to make sure that it works. And be honest with you, if I hadn't done that yet, I'm going to do it now, because that's going to make sure that I've got it right or it's wrong. And if it's wrong, I can go back, I can double check to make sure I typed in the calculator right, or go back here and make sure I didn't do something wrong here, right? So 1/6 times negative 36 is what? -6, that's right. Thank you guys for participating. And then 18 divided by 6 is going to be 3. Half of 36, let's see, that's going to be positive 18 minus 21, so we get -3. And this is going to be -9 plus 11, so we're going to get 2. Is this right? The chances of me getting whole number values and making lots of mistakes are pretty small, but it happens from time to time. What number is this? This is number 20. -6, 3, -3, and 2. We are right on the money, okay? And so to finish this out, step 4, I look for your work, right? And you can write it out like this. And of course, step 5 would be the last piece here, okay? And so I would try to break these down into, so if this was worth 5 points, I would give you 1 point per each piece until you stopped, until you made a mistake somewhere. And then that's as far as you go. Which means, if you just type this into your calculator, you don't show me any other work, you don't get any credit. You got to get progression through the thing to get credit for it, okay? So make sure you're giving me the steps. This is just preventing people from using the calculator the entire time, right? You're just not going to get a whole lot of points for that. You won't pass the test if you're going to kind of plan to do that. So don't hold on to that. To graph a translation or any kind of transformations, what I expect to see is, number one, I want to see the coordinate matrix, and you get that from either looking at the picture or writing down the coordinates. The x part goes across the top, and the y part goes across the bottom. For a translation, I have a matrix that I'm going to be adding. Here, I have 1s across in the x values. This means I'm going to go up 1 in the x direction, and then here it's, right in the x direction 1, and then up in the y direction 1. So that's where you have the 1s and the 1s. I add them together. I'm going to get the new values, the E prime, L prime, F prime, C prime. I'm going to graph these. So over x1 down to -3. So we would have a point here. This would be E prime. L prime is over 4 and then up 1. That's L prime. F prime is over 5, up 1. That's your F prime. And then C prime is 3, 1, 2, 3, and then -4. 1, 2, 3, 4. So this is going to be your C prime. So we end up getting a quadrilateral that looks like this. If you were to graph both of them, if you had time to do that, this question asked me just to graph the image. It did not ask to graph both, so I don't have to graph both of them. But I would expect to see the coordinate matrix, kind of the work you did to get there, and then the final solution on the graph. If it's multiple choice, then you can just pick the right answer and move on. Work wouldn't be necessary.